Hi, welcome back. So we're going to continue on. Now this last problem was given to me by an ex-girlfriend in college. And so she gave me this problem and said, hey, when you've solved it, give me a call, tell me what the message is. And I said, oh, yeah, why not? Notice we're getting tricky with it now. We do have another product rule. So when we take the first is just cosine of x times the derivative of sine, which is cosine of y. But be careful, there's an inside, that's our chain rule. We're going to multiply that by dy dx. Plus the second function, which is my sine of y, multiply that by the derivative of my first, which becomes negative sine of x. The derivative of cosine is negative sine. And that's going to equal, again, that's just a constant, so that's 0. If you're good, you can do the math here really quickly. I can solve for dy dx. And if I bring this over, it's going to become a positive sine x sine y. And I'm going to divide by this cosine x cosine y. And there's your answer. But if you want to find out the message, simplify. What is sine of x over cosine of x? Tangent of x. What's the sine of y over cosine of y? Tangent of y. So my girlfriend's name was Tanny, so I gave her the message. Thanks, Tanny. I really appreciated the problem. All right, number 6. All right, this is one where we're really going to appreciate why we use these parentheses or brackets right here. So let's take a look at number 6. Y is equal to the cotangent of x times y. When we take the derivative, we're going to get dy dx. This is just our chain rule. The derivative of cotangent, negative cosecant squared of xy. We're just going to leave that alone. But when I do the derivative of the inside, we have our product rule. The first times the derivative of the second plus the second times the derivative of the first. Not so pretty. We are going to distribute. So we would get dy dx equals, be careful when you distribute. It's not that bad to do. We will get negative cosecant squared of xy times x dy dx minus, I'm distributing here to both, cosecant squared of xy times y. Be careful on the algebra. Go slow with it. Now, notice I have two terms with a dx, dy, dx, but they're on opposite sides. So I'm going to think of an easier problem. If I have something like x equals 5x minus 3, I'm going to bring that 5x over. I'm going to do the same thing here. So I'm going to bring this whole term over, and I would get dy dx plus cosecant squared of xy times x dy dx equal to negative cosecant squared of xy times y. Please don't make that y squared. Just leave it alone. That's the y is not times all that. And now I have my dy dx on the one side, and I can factor that out. Dy dx, this is going to become, be careful, there's a 1 here, 1 plus cosecant squared of xy times x, don't forget the times x, equals negative cosecant squared of xy times y. And I just divide. Dy dx, we're going to get negative cosecant squared of xy times y divided by 1 plus cosecant squared of xy times x. And there is our derivative. That is a nasty little bugger of a problem. Whew! Glad it's over. All right, next one. Ready? Oh, no. I know what y'all thinking. Mr. Werner, this stuff is all pretty cool, but how's it going to help me with my tangent lines? Let's find out. Oh, look, there it is. Find the slope of this tangent line of this graph. X to the 2/3 plus y to the 2/3 is 2. And here it is. We want to find the slope at this point right here. We want to find out what that slope is. Okay, it looks kind of like it might be -1. It looks like it. I'm not sure. Let's find out. So to find the slope, we're looking for the slope, which is our derivative, dy dx. So let's take our derivative. X is easy. That's just 2/3 x to the negative 1/3. Plus, be careful of the y. We're going to get 2/3 y to the negative 1/3, but what did our rule say? If taking the derivative of a y, multiply by dy dx. So I got to multiply this by dy dx. And the derivative of 2, well, that's just 0 right there. I'm going to solve. Now, before I solve, I've kind of been trying to tricking you a little bit. I can divide by 2/3. Divide everything by 2/3. That's going to cancel here. X to the negative 1/3 plus y to the negative 1/3 dy dx. That's just going to equal 0. And now when I solve, dy dx is going to become negative x to the negative 1/3 over y to the negative 1/3. I'm going to switch those around. I don't like those negative exponents. So I'll make that y to the 1/3 over x to the 1/3. And there's our derivative right there. We're not done. We want to find the slope at the point 1, 1. So let's go ahead and now watch this notation, dy dx, such that we're at the point 1, 1. And we're just going to plug in a 1 here, right here. Oh, got my negative. Sorry, got my negative there. When I plug this in, negative 1 to the 1/3 is 1. X to the 1/3, which is 1. So we just get negative 1, which is kind of like what we thought it would be, by the way. Now, they don't ask it here, but could I write the tangent line right now? You betcha. Y minus 1 equals negative 1, x minus 1. And there's our derivative. They're not asking for it, but we just want to find the slope. We just want the slope here, okay? Now, number 8, they ask for a tangent line. So let's kick it. All right, here we go. Got to take the derivative. Oh, no. 2 product rules. No problem. Remember, to find this tangent line, we need a point, which they give me, 1, 2, and we need the slope. So to get the slope, we need our derivative, dy dx. There we go. So let's take our derivative, product rule, the first, times the derivative of the second, plus the second, times the derivative of the first, 2x. Minus, now over here, I'm going to use a bracket because that minus is going to mess me up. The first times the derivative of the second, took the derivative of y, dy dx, plus the second, y squared, times the derivative of the first, which is just 1. And that's going to equal 0. Don't do all that beautiful calculus and forget that's just a constant. That's going to become 0. Distribute the negative. X squared dy dx plus 2xy minus 2xy dy dx minus y squared equal to 0. And let's see how good we are. Let's see if we can do this real quickly. Ready? Let's get our slope real quickly. Anything with the dy dx, remember, is going to stay. We're going to get dy dx. Watch this. I'm going to bring over everything else. That should be next. I'm going to bring over the y squared and this 2xy. Everybody okay with that? Yeah, we're just going to bring those over, Mr. Werner. That's pretty chill. But remember, I'm factoring out the dy dx, and then I'm going to divide by the x squared minus 2xy. And there's our derivative. So to get the slope, let's use that crazy notation we just learned on the past problem. At the point 1, 2, and we just plug it in. We're going to get 2 squared minus 2 times 1 times 2, because x times y, over 1 squared minus 2 times 1 times 2. And I can simplify that. And if you clean all of that up, we're going to get 4 minus 4. Oh, how boring is that? It's just going to become 0. Oh, all right, so, there's 0. Yeah, 4 minus 4 is 0. So my tangent line, y minus 2 equals 0, x minus 1. People always ask me, well, now, do we have to write it this way? I do. You could just go y equals 2 as well. I hope you enjoy these videos, okay? You guys have fun. I will see you all later.